Okay, I'm going to record myself going through this, but just know I'm not feeling well, so my voice is a bit rough. But I just want to go through and explain these as we do these. And remember, the first 10 are definitely going to be without a calculator. So the very beginning of this chapter, you have to know how to evaluate trig functions using the unit circle or using special triangles. And if it's bigger than 360, remember you just subtract 360. And yes, without a calculator, I believe you can do that. So what would that be? 495, and then I can subtract 360 again, and that would be 135 degrees. And so I want to look on my circle of where 135 degrees is, which is right here. And the ordered pairs there would be negative square root of 2 over 2, comma, square root of 2 over 2. And so the tangent of that is just y over x, right? Tangent is y over x. So the answer to that is negative 1. Where's the cosine of negative 3 pi? That one you can just kind of figure out where it is, or you can add 2 pi, and then that's negative pi, and then you can add 2 pi again, and that's the same as pi. So you want to know what is the cosine of pi. Pi is over here, and that's the ordered pair negative 1, 0, and remember that cosine is x. So this happens to also be negative 1. This happens to just be what they picked, but it could be anything, right? So maybe review knowing your unit circle and knowing the ratios for sine, cosine, and tangent and the reciprocals. Number 2, it feels like forever since we did something like this, but if they just give you a point, right, you can graph that point. So negative 3, negative 8, I'm going to say that's about right here. If I call this negative 8 and this negative 3, not drawn to scale, then I can draw a triangle in. The vertical distance is the y, the horizontal distance is the x, and then I can just do Pythagorean theorem to find the hypotenuse, or the r. So r equals 8 squared plus 3 squared, which is 64, plus 9, which is what, square root of 77? 73? Gosh, I can't even add. And then, so give it a point, you can draw a triangle, you can solve for the missing side, and then you just solve for whatever it asks for. So this one asks for cosecant. Your angle is coming from here. Cosecant is the reciprocal of sine. So cosecant is r over y. So that would just be the square root of 73 over negative 8. If you can simplify your square root, you're going to do that. But if you can't, just like this one, you're going to leave it like that. Amplitude period, phase shift, and maximum value. If you remember when we took the test over this, you had to do this and graph it. For this final, you only have to know these formulas. And so if you get your unit 2 packet out, it has the rules for all of this. So like remember, if it's like y equals a times the sine of bx minus c plus d. So for amplitude, remember that amplitude is the absolute value of a because it's the distance. So on this one, the amplitude is 3. It's kind of how much it's stretched. The period is 2 pi over b. So in this case, that's 2 pi over 1/2 without a calculator. Remember that dividing by 1/2 is the same as multiplying by the reciprocal. So that's really 2 pi times 2 over 1. So that's really 4 pi. The phase shift. Phase shift is c over b, but remember, it's the opposite sign of what's in here because it's like a horizontal shift. So this is really negative pi tenths divided by 1/2. And again, don't try to do it in your head. Dividing by 1/2 is the same as multiplying by 2 over 1. So that's really negative pi fifths. And then the vertical shift is negative 4, but they don't ask for that. They ask for the maximum. And remember to find the max or the min. The biggest sign ever is 1, and the smallest it is 0. So if you take and you replace all of the sign part with 1, and you replace it with negative 1, the biggest number is your max, and the smallest number is your min. So on this one, since the bigger number is -1, then that would be my max value. -7 would be my min value. And so you just need to look over those formulas to make sure that you can do them for the test. Polar coordinates. Remember that polar coordinates are r theta, where you can graph. You have those circles that you're graphing. We had a question just like this on our test. Two things, okay? One, there could be more than one answer to this. Remember that if you have r theta, if you leave r the same, you can add and subtract any multiple of 2 pi, just like with our angles, and you haven't changed. So I always just take this and I look at, if I added 2 pi would be 8 pi fourths, and that would be 11 pi fourths, but that's not up there. If I subtracted 8 pi fourths, that would be -5 pi fourths. So r didn't change, but -5 pi fourths, that's an answer. 7 pi fourths is not an answer because 7 pi fourths isn't big enough. It's not 11 pi fourths. But then the other thing is, remember that if you change the value of r, you can't really graph a -r. So a -r really means a reflection. Then you can add and subtract multiples of pi, like 1 pi, 3 pi, and so forth. And so for 3 pi fourths, if I subtract pi, like 4 pi fourths, then I get C as an answer. But -3 pi fourths, that's not going to be something I get by subtracting pi. So usually on this, there's two answers, one with a positive r and one with a negative r. So the answers on this is both B and C. So it's kind of a multiple choice, but there's two answers. Number 6. First thing, this is a unit circle question of saying, where does cosine equal -square root of 2 over 2? Cosine is x, and cosine is negative in quadrant 2 and quadrant 3. So if this was just x here, you would say x equals, but it's 7x. So we say 7x equals 3 pi fourths. And since it says all solutions, I would say plus 2 pi n. And down here, that would be what, 5 pi fourths? So also 7x equals 5 pi fourths plus 2 pi n. So we have to solve for x, so we have to divide by 7. And remember, we also have to divide the 2 pi n by 7. And again, without a calculator, remember dividing by 7 is the same as multiplying by 1/7. So I would get 3 pi over 28 plus 2 pi 7ths n. And the same thing on this one, I'm going to divide by 7, and I would get 5 pi over 28 plus 2 pi 7ths n. And so remember to divide everything by that. And they're not going to ask you the question of, like, give me all the answers between 0 and 360, because that would be 14 answers. And we wouldn't want to do that. Number 7 seems more recent than some of the other ones that we've done. I feel like that was Unit 3, number 7 here, of a complex number in trig form. So they already gave us this in the KISS form, like the cosine I sine, and they just ask us for different things. So for u times v times w, remember you multiply the r's, so 10 times 2 times 5, and you add the thetas, so 100 plus 70 plus 210 degrees. So 20 times 5 is 100. And then this would be 380, right? But it says express your angle between 0 and 360. So you just subtract 360 from 380 to get 100 KISS 20. Remember, when we divide complex numbers in trig form, we divide the r's, so u and w, so be careful not to use v on this one. So it would be 10 over 5, and you subtract the angles. So 100 minus 210. And again, we're going to get an angle outside of our area here. So we're going to get negative 110 degrees. But it says to give one between 0 and 360. So again, I'm just going to add 360 to that. And I'm going to get 250 degrees. And then the last one is de Moivre's theorem. De Moivre's theorem says if I'm going to take v to the third, I need to erase this now. I'm going to take r to the third, so 2 to the third, and then I'm going to take the angle times that power. So I'm going to get 8 kiss. That's just 210, right? So again, it's just knowing those formulas. The conic stuff that we just did hopefully is most recent in your brain. Parabola. I feel like this is just like one that was on our test. But y squared minus 6y. I have to complete the square for the one that's not squared. I'm going to add 12x and add 15 to the other side. I'm going to take half of 6 and I'm going to square it. So I'm going to add 9 to both sides. And this becomes y minus 3 squared equals 12x plus 24. Factor out the 12. I might not make it. So remember, whichever one is squared tells you which way it opens. And when y is squared on a parabola, that means it opens left or right. Because this is a positive number, that means it opens right. So the vertex is h and k. Be careful, because the vertex is negative 2, positive 3. So that would be here, and it's going to open this way. This is equal to 4p. So 4p equals 12. So p equals 3. The focus is inside the parabola. So I'm going to move 3 to the right. And so if I add 3 to negative 2, that would be 1, I do believe. The directrix is a line behind it, so it's an equation, x equals or y equals. And since it's a vertical line, it's x equals, and it's just 3 the other way. So that would be x equals negative 5. Draw the picture. It's very helpful. You got to be able to complete the square. Okay, number 9 is inverse trig. And so the big thing to remember about this is your restriction. So remember that inverse cosine is restricted from 0 to pi, and both inverse tangent and inverse sine are restricted from negative pi halves to pi halves, because in order to have an inverse, it has to be 1 to 1, because you can't have the x's repeat. So when you flip them around, you can't have the y's repeat. So there's 2 types of questions they can give you. They can give you the sides, or they can give you the angle. When they give you the sides, it's not that bad. You do want to think about, even though cosine is negative in 2 places, in 0 to pi, it's either here or here. So it's only negative over here. So that means I would draw it over here. And it would be negative 6 over 13. And I would do Pythagorean theorem to get the square root of 13 squared minus 6 squared, right? So 169 minus 36 is 133. So you use the inside to draw your picture, and then you just find the tangent of this. So the tangent is just opposite over adjacent. When they give you the angle, it's a little bit trickier, because you still have to think about that I'm restricted because it's tangent between negative pi halves and pi halves. If my answer was in between there, then tangent and inverse tangent cancel out. But they don't cancel out if this angle is not in this region. So the first thing I'm going to do is I'm going to add 2 pi and try to get to an answer that's in this region. And then if it's not in the region, I have to think outside the box. But if I add 2 pi to this, that would be 18 pi ninths. And that would leave me negative 4 pi ninths. And I just have to think about, is negative 4 pi ninths in between negative pi halves and pi halves? And think about that pi halves and negative pi halves is a half. So the question is negative 4 pi ninths more than a half? And think about 4.5 pi ninths would equal pi halves. So it's close, it's really, really close, but it's not quite there, which means it is in this restriction. So as soon as you get something that's in that restriction, that's your answer. If it's not in the restriction, then you have to think about finding the reference angle to do that. Okay, last one for the no calculator part. There will be one question on your test that asks you to graph the parent function of one of these 4 things. Okay? I'm not going to tell you which one, but it will just be just sine, cosine, tangent, or cotangent. So let's go through really quick how to graph these. I hope that you remember sine and cosine. Remember that the period of sine and cosine is 2 pi, so you can graph 2 periods really easily by just going to 2 pi. And remember that, think about if you made an XY chart here, that if you start at 0 and you end at 2 pi, halfway in the middle is pi, you get pi halves and 3 pi halves. If you remember that sine is the y coordinate on the unit circle, you just go around the unit circle. At 0, the y value is 0. At pi halves, it's 1. Then it goes back to 0, down to negative 1, and back to 0. So sine starts at 0, it goes up to its high point, back to 0, down to its low point, back to 0. And I always say it's like 1 hump up, 1 hump down. And because sine is an odd function, it flips the opposite way when you go over the y-axis. That's 2 full periods of sine. If you graph cosine, and remember that cosine is the x-coordinate on the unit circle, you can do the same idea as we go here. Again, it only goes to 1 and negative 1. So, same idea, 0 to 2 pi, we take half of it, we take half of it again. But cosine is x, so cosine starts at 1, and then it goes to 0, and it goes to negative 1, 0, back to 1. And I'm just using my unit circle to do that. So remember that sine starts at 0, cosine starts at 1, and then it goes down to 0, it goes down, back to 0, back to 1. So 1 period of cosine kind of looks like the U shape. Cosine's an even function, so it looks exactly the same on both sides. Tangent and cotangent are a little bit tougher, but if you think about what they represent, tangent is y over x on the unit circle. So that's why tangent and cotangent have asymptotes. And I always start with those asymptotes. So tangent is undefined where x equals 0. And x equals 0 at pi halves and negative pi halves, at 3 pi halves, right? So you have like pi in the middle. That's when you have 0 in the middle. Negative 3 pi halves. You have negative pi in the middle. And so there's an asymptote here at negative pi halves, at pi halves, at 3 pi halves, at negative 3 pi halves. And if you make an XY chart, if you pick what's in the middle of your asymptotes, in between negative pi halves and pi halves, you get 0. And if you tangent of 0 would be 0 over 1, which is 0. And if you pick halfway in between those, which I'll just go ahead and mark these, halfway in between 0 and pi halves is pi fourths. And tangent of pi fourths is 1. Tangent of negative pi fourths is negative 1. So you get these little S-looking shapes. And what's nice about tangent, as soon as you get one of them, they just repeat itself over and over again. So one period of tangent is shorter than one period of sine and cosine. So they just make these little curves because they just keep getting bigger. Cotangent's the same way, except for think about what's going to be different. Cotangent is x over y, so the asymptotes are now going to be where x equals 0. So think about this, not where x is 0, where y is 0. Y is 0 at 0 and at pi, at negative pi. You can even say at 2 pi if you want. Halfway in between should still be your 0 here. Like if you plug pi halves in there, you get 0 over 1. But be really careful, because if you plug pi fourths in there, which is back here now, it goes up. And 3 pi fourths, it goes down. So remember that cotangent, it's like flipped, it goes the other way. This is an increasing function on tangent, it's a decreasing function on cotangent. But again, once you get one of them, oh, I about messed up. So negative pi fourths would be like this. Okay? So let me know what questions you have. This would be the no calculator part. And that's going to be, you take part of it on the regular day and part of it on the final day.